Mrs. Demedio here. Today, our topic lesson is on same perimeter and different area for topic 16.4. Let's look at our objective. I can understand the relationship of shapes with the same perimeter and different areas. Just a quick review. Remember, when you are trying to figure out the perimeter, you are adding. When you are trying to find the area, you're multiplying. So today we're going to try to find the same perimeter, but a different area. So let's look at some guided practice questions. Number 1. In the problem on page 866, which is what we're about to go back and look at, what do you notice about the area of the rectangles as the shape becomes more like a square? Let's take a look. So this is what we're talking about. We have our rectangles, and then we have our square. So the perimeter, you'll notice, is the same, but as if you're trying to multiply the sides, 1 unit times 5 squares is going to give you 5. Whereas with our area here, we have 2 squares times 4 is going to give us 8. So we start off with 5, then 8. Let's look at our square. Our perimeter, as I mentioned, is the same, but let's look at our area. So we have 3 times 3, so 3 feet times 3 feet is going to give us 9. So we start off with 5 square feet, 8 square feet, 9 square feet for the area. So let's look back at the question. What do you notice about the area of the rectangles as the shape becomes more like a square? Would you say the area decreases, goes down, or increases? If you said increases, you're right. So again, we're talking about same perimeter here, but different areas. Let's look at number 2. Austin is building a rabbit pen with 25 feet of fence. What are the dimensions of the rectangle he should build to have the greatest possible area? So as I've mentioned before, it's always important to annotate, even for math when you have word problems. So there's one word there that's going to help you. And you can ask yourself, am I trying to add by finding the perimeter, or am I going to find the area and I need to multiply? So if you went back and looked and noticed the word area, you're right. So we're going to multiply. So we have to find the total 25 feet. So what 2 numbers can you think about that will equal 25 feet? So let's think this is our area, 25. What should be our sides to equal 25? If you're thinking 5 feet times 5 feet, you're right, because 5 times 5 gives us 25. So then our answer would be 5 feet times or by 5 feet. Let's look at the rest. And 3 through 6, use grid paper to draw 2 different rectangles with the given perimeter. Tell the dimensions and area of each rectangle. Circle the one that has the greater area. So there's a lot going on in this problem or in these problems. First of all, it says to use grid paper. It's okay if you don't have grid paper, but grid paper will help you um, bring it down to each little unit square to draw two different rectangles with the given perimeter. Tell the dimensions and the area of each rectangle. Circle the one that has the greater area. So there's a lot going on. Let's take a look at number 3. So number 3 is 16 feet. I'm going to draw number 3 over here. It's important to know what you're drawing. Rectangles, that's right. So think about what numbers, what dimensions can help us give us 16 feet as our perimeter. We need 2. So if you're first thinking 2 feet, so 2 feet's here, 2 feet there because they're equal, times, or excuse me, so we have 2 plus 2. What other two numbers can give us 16? If you're thinking 6, so 2 plus 6 is 8. 8 plus 2 is 10, plus 6 will give us 16. But we're not done yet because we still need to draw our second rectangle. So what two other numbers, I'm going to erase that, a yucky rectangle. That gives you more time to think about what 2 or 4 other numbers you can get to equal 16 feet. This will just have to do. If you think 5 feet, and if this is 5, this has to be 5 as well. So 5 plus 5 is 10. So if we need to get to 16, what number should we put here? 5 plus 5 plus 3 is 13. We need a couple more to get to 16. Plus 3 more will give us 16. Now, we drew our 2 rectangles. Let's now put a perimeter, which is going to be the same underneath. So our perimeter is the same, but our area is going to be different. So now we're going to try to multiply to find our area and see which one of those rectangles has the greater area. So let's multiply 6 times 2, and that's going to give us 12. And if we multiply 5 times 3, that's going to give us 15. So out of these 2 rectangles, which one has the greater area? If you thought 15 feet, you're right. Let's move on to number 4, just to get more of a hang of it. So our same perimeter now, and if it's all right with you, I'm going to erase this, is no longer 16 feet, but 20 feet. Sorry, 20 centimeters. We're using different measurements. So think of what 4 numbers can equal 20. Here's one of them. 6 plus 6 gives us 12. So what 2 other numbers do we need to give us 20? How about 4? So 6 plus 6 is 12. Plus 4, 16. And if this is 4, it needs to be equal 4. So this all equals 20. Now we need to find another rectangle that has that same perimeter. Start with 7, and this side is 7. This side needs to be equal to, so we need to get to 20. So 7 plus 7 gives us 14. Now, what other two numbers do we need to give us 20? If you're thinking 3 here, 3 here, that gives us 20. Are we done? If you're shaking your head, you're right. We're not done. We have to find our area. We need to find which one has the greater area. So are we going to add now? Good. If you shake your head one more time. We're not going to add. We're going to multiply. So let's take this rectangle first. We have 4 times 6. It's going to give us 24. And if you want to be very specific and fancy, you can put a little square there. That means you're multiplying. 3 times 7 is going to give us 21 centimeters square. So out of the two of these, which one has the greater area? You're right, 24. How do you feel about that so far? Let's take a look at our independent practice now. Use grid paper to draw two different rectangles with the given perimeter. Let's annotate. So as I said, it's okay if you don't have grid paper, but grid paper will definitely break it down. It'll be more precise. Two different rectangles. Tell the dimensions and area of each rectangle. Circle the one that's the greater area. You might say, we did this already. You're right, we did. Now we're going to do it again with different dimensions. If it's all right with you, I'm going to erase this side just so we have space. Number 7 is 10 inches. So think about what 4 numbers do we need to equal 10? We're not multiplying, we are adding since it is perimeter. If you're thinking 4, and if this is 4, this must be 4. So 4 plus 4 is 8. So what other numbers do you need here to give you 10? If you are thinking 1, 1, that's going to give you 10. But we're not done yet. We need 2 different rectangles. So now think again, what other numbers can we get that are different but still give us the same perimeter of 10 inches? You're thinking 3. If 3 is here and this side is equal, 3 plus 3, which gives us 6. Now, what other numbers do we need here to give us 10? If you're thinking 2 plus 2, that'll definitely give us the same perimeter of 10 inches. But are we done yet? No, you're right, we're not. Now we need to find the greater area. So now we need to multiply. Let's take this rectangle first. 1 times 4 will give us 4 inches. Or, as I mentioned, to be fancy, to be specific and precise, 4 square inches. Now let's take our area over here. 2 times 3 is going to give us 6 square inches. Now ask yourself which one has the greater area, 4 square inches or 6 square inches. If you thought 6, you're right. Let's do one more together. Number 8. "22 centimeters." I want you to start thinking before I get started with you. What 4 numbers can we add all together to get 22 centimeters? Think of 2 rectangles that you can add. If you're thinking 8 plus 8 is going to give us 16. What other numbers do we need here on the side to give us 22? If you're thinking 3, you're right. So 16, 8 plus 8, 16, plus 3 is going to give us 19, plus 3 more is going to give us 22. But we're not done yet because it wants us to find 2 different rectangles with the same perimeter. So stop and think of another rectangle that has the same perimeter. If you're thinking 9 plus 9 gives us 18. What other 2 numbers do we need to give us 22? That's right, 2 plus 2 gives us 22. Because 18 plus 2 is 20, 20 plus 2 is 22. Same perimeter. But we're not done yet. As we've mentioned, we still need to find the rectangle with the greatest area. So now we're going to switch off from addition to multiplication. So let's take a look at this first rectangle. We're going to take 8 inches by 3, which is going to give us 24 square centimeters. Let's look at this rectangle now. We have 9 centimeters times 2 centimeters is going to give us 18 square centimeters. So out of the 2 areas, which one has the greatest or greater area? You're right, it would be 24 centimeters. These problems take time. It's not that they're hard, but they are time consuming. So take your time on them. Find the same perimeter, then try to find the greater area. Try to do some practice problems before moving on to your quick check. Bye.